All right, this is the experiment that was in our notes last time that a student designed to see if caffeine affected pulse rate. So he said, all right, let's pretend it's this class. All of you take your pulse rate, and then I'm going to give you a can of Coke. We'll wait a few minutes, take your pulse rate again, and then compare. Well, we talked last time about some variables that could influence your pulse rate other than the caffeine. So it's really hard to create this cause and effect relationship between caffeine and pulse rate because there are some lurking variables. What are some of those things we mentioned last time that could affect pulse rate during this experiment? The placebo effect might. What did you say? Stress. If you are having a particularly stressful day or something stressful happens while the experiment is taking place, an environmental factor is what we would call that. That could increase your pulse rate. What else is in soda that could increase pulse rate? Sugar is what we had mentioned last time. All right. Let's see. Give specific examples of sources of confounding and explain how to avoid them. Sugar could cause an increase in pulse rate. Sugar could cause an increase in pulse rate. That's really easy to avoid. Use diet soda. Environmental factors. Like temperature, stress, etc. Now, you can't really avoid somebody in your experiment being stressed that day, but you would just take care to make sure that every single person in the experiment was in a similar environment, as similar as possible, and we'll talk about that more in just a second. Somebody had mentioned the placebo effect. Let's go ahead and just write that down. What is that? What is the placebo effect? First of all, what is a placebo? Do you remember? You don't have to say the fancy definition, but to you, what is a placebo? If I gave you a placebo soda in this experiment, what would that be?
It's kind of like a fake.
It's a fake, yeah. It looks, tastes, smells just like the soda that has the caffeine, but it wouldn't have any caffeine in it. And we just mentioned a second ago about double blind. We would want to make sure nobody knew what kind of soda they were getting to eliminate that. So the placebo effect would be if I tell you, hey, you're getting caffeine, well, it's more than likely going to happen that your pulse rate increases. If you think you're getting the fake one, then your pulse rate may not increase just because of what your mind does. So to avoid that, avoid by making experiment double blind. That will also eliminate sources of bias. The next part is going to seem a little redundant, but it's just going to give more specificity, more specific talk about this. It says in the example above, many other variables affect pulse rate besides caffeine. That's what we just talked about. List some variables for the subjects and the experimental process. So there's a difference. There are variables within the subjects themselves, the people. And that could be like their weight, caffeine tolerance. Some people aren't really affected by caffeine a whole lot. Their heart rate doesn't really increase a lot. They can have coffee at bedtime, no big deal. But if you're a person who abstains from caffeine, one time I quit drinking coffee. I kind of weaned myself off of it, quit drinking coffee, and switched to caffeine free, or decaf, excuse me. And when I started drinking it again, my tolerance had gone down significantly, and my heart did definitely race, and I did not feel good at all. How recently they've consumed their coffee, and then stress level, kind of just their health in general. Those are the variables within the subjects themselves, the people. Well, there are variables in the experimental process that will affect pulse rate as well. And those are more like the environmental factors, or like the sugar content. That's the sugar content in the soda, not in the people, okay? The amount of soda. Maybe a person has, doesn't really react adversely to a can of Coke, but if they drank a liter, then they would have an increased pulse rate. So the amount consumed, and then like the temperature of the room. Those are experimental process variables. So if you're asked to distinguish between the types of variables, just think if it's in the person, then that's in the subject, and anything else would be considered experimental process variable. Okay, let's talk about how important it is to randomly assign treatments. To experiment well, we want to create groups that are as similar as possible and treated in exactly the same way, other than the response variable. That's going to be an answer on your quiz next time, and it's going to be an answer to a test question where I ask you, hey, why is it important to randomly assign treatments? Well, we want to create groups that are as similar as possible. That's the main reason we want to randomly assign people to their groups. If treatments are given to groups that differ greatly when the experiment begins, confounding is likely. For instance, if I put everybody that's generally healthy and fit in one group, and then the other group has a poor fitness, or they have health issues, then I'm going to get completely different results. I want both of my groups to be as alike as possible, and that's why we need to randomly assign. Letting subjects choose their group is not a good idea, since bias and additional variables will still be present, so the solution is random assignment. Here's what random assignment is. Treatments are assigned to experimental units or subjects if they're people, or you could actually assign your people to a specific treatment. It works either way, but it's when you randomly assign using a chance process. That word chance always shows up in our class, especially in the next chapter. I don't think any of you will have a difficult time spotting the definition for random assignment on a test or quiz, okay? That's pretty obvious. It's when treatments are assigned at random using a chance process. Here's an example. In Mr. Smith's class, 20 students volunteered to participate in the caffeine experiment. Design how you would randomly, I think this should say explain. Explain how you would randomly design, that should say assign. Good Lord. 10 students to each treatment. Apparently I really liked the word design that day. Part A says, how would you randomly assign 10 students to each group using slips of paper? That seems totally weird, but you would just write everybody's name in the class, or these 20 people's names on slips of paper, and then the first 10 that you draw out go in one group, the next 10 that you, or the 10 that are left go in the other group, okay? That's how you can give your answer on your homework when it says to describe it using slips of paper. So we would have a slip of paper for each student, for each of the 20 students with their name on it. Obviously, you shuffle all those together, and then you could pull the first 10 names would go in group A. The other 10 go to group B. I won't make you write this other part, but just listen. You could also just put slips of paper in a hat that, 10 of them say A and 10 of them say B, and then a student comes up and pulls a slip of paper, and if it says A, they go to that treatment. If it says B, they go to that treatment. So that goes back to you can flip-flop it. You can assign a treatment to a student, or you could assign a student to a treatment. There are different ways to do that, but either way, it's random. And then just to kind of recall something that we haven't done since way back before Christmas break, use a random number generator, aka your calculator, to do this. So here's what you would do, okay? I would give all 20 students a number, okay? Your student 1, your student 2, blah, 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 all the way to student 20. And then I would hit math, go to the probability menu, and then I would say, all right, I don't want any of these numbers to repeat as I'm assigning the first 10 students. So I would click this one. I would have my students numbered 1 to 20. So then I would enter 1, 20. And this gives me all 20 numbers shuffled. So I would say, all right, the first 10 students on this list are going to do treatment A. So student number 19, student number 8, 13, 1, 12, and then you just arrow over until you get the first 10. And then, hey, everybody else, you're in group B. So that's how you would do it. So let's just write here. You would use rand integer no repeat. It looks like this. Rand int no rep. You would have each student assigned a number. You would use your calculator input like this, and then the first 10 students listed would be randomly assigned to group A, and then the last 10 to group B. You won't have to do that today, so if you don't have a calculator, it's no big deal, but I just wanted to remind you of how. Turn the page. There are the steps to do that. Again, if you're interested, let's look at example 2. Gosh, there's a lot to read. Many people blame TV for the increasing problem of obesity. Does the type of show you watch influence how much you eat? According to a recent study, the answer is yes. 94 college students were randomly assigned to one of 3 treatments. Here are the 3 treatments. Watching 20 minutes of an action movie, watching the same 20-minute clip of the action movie without sound, and watching 20 minutes of an interview show. While watching, the subjects were given snacks, M&Ms, cookies, carrots, and grapes, so there's some unhealthy and some healthy, and they were allowed to eat as much as they wanted. Subjects who watched the movie clip with sound, so the action movie with sound, consumed a lot more calories than those who watched the interview. 65% more calories, okay? Participants who watched the action movie without sound still consumed more, 45% more calories than those who watched the interview. Explain the purpose of random assignment. Now, we're going to revisit this whole little scenario and some other questions coming up. But for now, I just want you to tell me, why is it important that we take those 94 college students and we randomly assign them to each treatment instead of saying, hey, you can choose whichever you want. If you want to watch the action movie, fine. If you want to watch the interview, fine. We don't want them to choose. Why is it important? I'm going to go back to this. Why is it important to randomly assign people to treatments? Here's the answer. I'm going to copy that down, copy it down, because that's the answer. We want to create groups that are as similar as possible. That's always the answer. We want to create 3 groups that are as similar as possible. To prevent confounding. Let's just tack that on there. We don't want all the hungry people to watch the action movie. That would throw off the results. So we want all the groups to be the same. A good mix of people doing all 3. That's pretty much it. Now again, we're going to revisit that giant paragraph of a problem here in just a little while. So there are other sources of variability that come into play. Again, it kind of seems like there's never a perfect way to design an experiment. There's always something else that could be lurking. In the caffeine experiment, there are other variables that might have an impact on the response, which is pulse rate. We already talked about this over and over and over again. Sugar, amount of soda, temperature. Because of this, steps should be taken to ensure each subject receives the same amount of sugar, they receive the same amount of soda, and they have to be in different. If you have to split them up and like part of my students are in this room and the other half of the students go to like Miss Lopez's room, I would want to make sure that our rooms are as similar as possible in environment so that variable would be removed. The dot plots show the results for, okay, look really closely with me. Here's dot plot A, the one on the left. That's an experiment in which the amount of soda was the same for all students. Amount of soda, same for all. Dot plot B over here, students got to choose how much soda they drank. Students choose amount of soda. Now let's kind of analyze these dot plots and see the difference. When we talk about variability, we talk about the difference, okay? Notice the distribution on the right is much more variable. The increased overlap in the graph makes the evidence supporting the effect of caffeine less convincing. Here's all that is saying, okay? Over here, the well-designed experiment where everyone gets the same amount, check this out. It's really easy for me to see as the researcher that caffeine, the dots for caffeine, if you kind of group those together, the pulse rates are much higher than the group with no caffeine. It's easy for me to tell that. The change in pulse rate is higher for those that consume caffeine. There's not really a lot of overlap there. Versus, look at this one. When students get to choose, all the caffeine people, they're spread out a lot. There's a lot of variability. Well, and the no caffeine people are also really spread out, and there's a ton of overlap. So it's really hard to see if caffeine really did affect the pulse rate. So I just want you to make a little note. This one has more variability. Which is bad. It's more spread out. There's overlap, which is also bad. It's harder to tell if there was truly a difference when students got to choose the amount. The variability went up. It's more spread out. And we are finally on the last page of notes. Here are the main takeaways about the reasons why we must keep all variables the same. We want to prevent confounding, and we want to reduce variability in the response variable. Those are the takeaways. That's why it's so important to really think about how you're designing your experiment. You want to avoid confounding, and reduce variability. All right, let's revisit that TV thing. This one's pretty easy, and then we'll be done. In the TV and snacks example, researchers determined that people typically consume more calories when watching TV shows that are more entertaining, so that action movie. Identify two variables that researchers kept the same. Identify two variables that researchers kept the same for all subjects, and provide reasons why it was important for them to do that. Provide reasons why it was important. I think you guys can do this without a lot of help from me. In that TV experiment, what was something that they kept the same for every single one of the 94 students that volunteered to do this? The snacks were all the same. Very good. That's one. So snack types. Why was it important? It says provide reasons why it was important to keep the snack types the same. Why do you think it was important?
Because they can choose for themselves.
It allows the people to choose for themselves. And then why would I want to make sure there's a good mixture of like healthy and unhealthy instead of you guys get the M&Ms and the candy and the junk and you guys get the healthy stuff?
Because the experiments try to see what they eat depending on what the class.
Exactly. We want to see if more calories are consumed, what kind of foods they choose. Okay, very good. So we want to make sure that the amount of calories isn't higher. We want to make sure that the amount of calories consumed isn't higher just because students are provided with different snack options. So we want to make sure that the amount of calories consumed isn't higher just because snacks are different. We're avoiding that confounding by giving everybody the same snack. Now it said identify two variables that were the same for everybody. So snack types is one. What else was kept the same for every single person?
Watch time.
The 20 minutes of time. Okay, the length of the show, or length of clip, the 20 minutes. And really there, what we're trying to do is make sure that people didn't just eat more because they watched for longer periods of time. Everybody is doing the same amount of watching, and so that's how they can kind of prevent the confounding there. So we want to make sure the reason people consume more calories, we want to make sure the reason people consume more calories isn't because they watched for a longer period of time. So the takeaways from today, random assignment is hugely important to keep your groups very similar. We always want to prevent confounding. There's a ton of ways to do that. And then we want to reduce the variability. We want to make sure things aren't very spread out. We want to keep them grouped together on a dot plot. That's it. And your assignment is on Schoology.